especially the query processor, especially the query optimization. Okay, so we have seen how to decide the cost of the selection. There are several factors we need to consider when we optimize the query. Okay, we have seen a lot. So however, we are going to consider two main operations. That is a selection and join operation. In addition to that, there are much more. In case of join, the left outer join, right outer join, full outer join, or when we process a query, it needs sometimes order by or group by and so on. But the important operation are the selection and join operation. So we simplify the problem of the query optimization by focusing on these two operations. The first one was the selection that we had reviewed the last time. So in selection, first we need to understand how many different ways of this selection. As if we are considering the travel to New York, so how many different ways to go to New York, Manhattan? So there are a bunch of different ways. Then decide the cost. When we have a trip, so our cost probably the money, which one is the cheapest one. Also time, okay? But in our optimization problem, our cost can be calculated by what? Number of I/O, input and output, to the what? The storage. Okay, that is the most expensive operation. In addition to that I/O, there are a bunch of others actually. Memory I/O and the CPU overhead and the transfer, the network overhead. There are so many, but they are relatively small or the less expensive. So we are going to count the number of the I/O. So we learn the cost function for each, as we have seen in this handout. This is nothing but summary of the textbook, so you can easily see the linear search. But don't be confused. The common mistake by the student is the primary index is not the primary keyword, the B+3. Primary index means it's a primary index for ordered file, ordered data file. So in general, for example, Oracle, does Oracle have the primary index? No, because most of the data file tables are non-ordered file, which means there is no primary index. Instead, secondary index will be used. However, if your data file is automatically sorted, so you have the sorted by the primary key table, then you can create the primary index. Okay? So don't be confused there. Most frequently used index is what? The secondary index, B+3 index. Secondary index means in case, even though data file is sorted, but we are not going to use that column. Instead, other non-sorted column will be indexed. That is the B+3 index, secondary index. How many secondary index? As many as possible. If you want to create the one column index, yes. Another, yes. Another, even sometimes you can make the composite index. One of the exception of such a non-ordered secondary index is the index organized table. The ordered file is the index organized. Actually, index organized table is not the ordered file, but we can consider it's the ordered file. Because the index organized table, we are going to include the data file to the indexing structure. Okay? It's a very special case that we are going to implement. So first, you need to design your B+3 indexing structure in your project that add data file structure in addition to the indexing file. So when you implement the second project, IoT, first you need to understand B+3 indexing structure, then how to create instead of the key entry. What is a key entry? It's a key plus at the location. We don't need the location. We don't need page number. We don't need the address pointer. Okay? Because we are going to include, instead of that pointer, we will create a table structure, column record structure. So those who are confusing still to prepare the project, why don't you combine the GA, make the appointment, so GA can provide more the ideas how to implement the indexing the IoT. Okay? Because he said he expected many questions, so he was ready. He prepared many answers, but he said the GA. First, the GA said there are not much questions, so which means the students are doing very well. So please, if you have any questions about your project before the Thanksgiving, why don't you come by and set up the appointment, or you can come by during his office hour to get more ideas how to start your project. Okay, then using the recursive function, we have the example of such a recursive function in real case. These are the statistics in our database, for example. So we have the table. One table is an employee table that includes the 10,000, the record, tuple, rows, whatever. And we have because we are not going to count the number of the record that we are going to read. Instead, our I/O is based on what? Blocks. So it's a block-based approach. So maybe next semester or the next semester, I'm going to ask to the student for the project block-based table or block-based index. It's much difficult because you need to understand operating system concept also. So anyway, we are pretend this is a block-based approach. So we are going to count the number of blocks. To do that, we should know how many records are in one block. So then we can calculate number of blocks for the employee, something like that. Also, we have the one index, cluster index, secondary index for SSA, another secondary index for DL, and another secondary index for sex. Right? Then for each index, most important thing is level of that index, because that determines I/O. 1, 2, 3, 4, 1, 2, and 1. Then one more to the data file. So that's usually happen. Also, in case of the range query, we are going to use the leaf node using through the sibling pointer. Do you remember that? So we have the sibling pointer from the leaf node. We don't have to up and down to find the exact value. Instead, we can keep going because they are already sorted. If you take a look at your homework for the B+3, the leaf node actually sorted, right? So we don't have to up and down, up and down. Up and down means from the root node, find the leaf node. Once you find the starting, then you can keep going to the right, okay, using the sibling pointer. Because of that, we need how many leaf nodes we have. So leaf node in this case are 4. Then we can calculate how many I/Os are needed. So for example, this one. So we have already seen. So let's take a look at this. So this is a range query. This is a equality. Okay, identical except the operation. So that if we count always brute force way, linear search is always the option. Like no matter where you go, no matter how you go. So running or walking can be your option, right? It will take a longer time, but you don't cost it's costly sometimes. But anyway, so it can be the option. So always is the option. So we are going to calculate the cost of the brute force, linear search. So in this case, it will be 2,000. Why is not the half of the 2,000? So we have seen the half of 2,000. Half of 2,000 is exact matching. Once you find it, that's it. Okay? So if we are lucky, from the first one. If we are not lucky, end of the block. So it's on average half. However, if you are doing the range query, once you find the data, then it's not done yet. You don't know whether this other data is bigger than the 5 or not. So you need to check all of the blocks. Okay? So that is the reason you need to check read all the block, that is a 2,000. Also this one is even though 5, this is not the primary key. So we already see the distinct value. Only the 125 distinct value and selectivity. For each, on average, for each department, 80 employees. Which means we need to visit all the block to find the employee that get satisfied with this condition. So it's always 2000. However, if we are using the index of the, in this case, what? So this is the secondary index for the NO at that time. This is looks like this. Then how many leaf? This one. Okay, 1, 2, then with the leaf block. For the leaf block, if we are lucky, it's the last one. If we are not lucky, it's the start first block. So on average, it's a half. That is the reason it's a half. Then for each, we need to visit this one. Also, this is a range query. So it will be, why is not the 2000? Because it's a record by record. Okay, so roughly you will, on average, you need to visit the 5,000 employees. Okay, so because of this, a 5,004. What about this one? This is a 5. Okay, is DNO is equal to 5. Okay, so that is the 2. It's the same thing. And for this one, how many? It has the 80. Okay, it's a selectivity. For each department, it's only 80. So it's total 82. So we can select this for the equality. But this one, the brute force way is faster. So that shows not always indexing is the fastest way. Okay, that is a common mistake, really. So when you develop the database project, so if your query is slow, you try to, most of the developer, they try to create a new index. However, index does not provide, that cannot guarantee the fastest way. Okay, it's one of the way. Okay, depending on the situation, depending on the cardinality, selectivity, it can be slower than the brute force way. For example, if your system is not online transaction processing, in other words, for example, it's a data warehousing system, throughput, number of throughput is important. At that time, usually, not always, but usually the linear search is faster rather than the indexing search. Okay. Then the next one is the join condition. So last time we have seen what is a join selectivity. Join selectivity means how many percentile or how many tuples between R and S. R is called outer table, inner table, driving table, driven table. Okay? So between the outer table, inner table, how many percentile of the matched one? That is the join selectivity. So join selectivity, then result. After the join operation, the number of R and number of S will be returned. So that is that will be used for the calculation of the join operation. First one is the nested loop join. So let's go back to the beginning. What is the nested loop join? What is a nested loop join? For each driving table, for each outer table, first row, check all the rows with the join condition. This join condition, whether one or same one. Then next, check all of them. Then next, check all of them. Okay? So this is the nested loop join. So nested loop join, first we need to read all of outer, okay, number of block of the outer driving table. Then this is the, for each you need to read all of the inner table. Okay, first you need to read, then you need to read how many times? BR times BS. For each you need to read this, all of this, all of this, all of this. So BR plus BR times BS. Then this is the join selectivity. How many? Because among, if not matched anything, you don't need any other the IO. However, if some of them are matched, you need to keep. Okay, you need to keep such a data. Okay, by reading. So that is the join selectivity percentile. How many of them are matched for the R and S? Then divide by buffering factor. Okay, because it's a number of the record, matched record. Then divide by buffering factor. This is the join join the blocks. Okay, so for simply this one is the left hand side, this is the right hand side, how many times, and this one is the matched one for to keep as the joined. Okay, the column, join the data record. So this is the nested loop join. Okay, what about the single loop join? What is the difference between the nested loop and single loop? Nested loop, you need is all the combination, right? Then check the join condition. But single loop join is the for the driving table or outer table. You don't have to check all the tuple. Instead, using index, directly find the matched one. How? For example, if join condition D n is equal to D number, so this is a D number. So D n is a 1. Using index of the D number in S, you can find the directory, the tuple in S. You don't have to visit all of them. Just like if you know the name, if you know the ID, you can directly find such a data using index, right? So at that time, you don't have to visit all of the inner table. Instead, directly find. How many loop? This one is loop. For each loop, we have another loop, nested loop. But this one is only one loop. One times of the loop, that is called a single loop join. So cost may be different. How different? So depending on the indexing structure that you are going to use to search the data from S, it can be various. However, idea is the same. So you can see the anyway you need to read the one loop one time. That is the EI. Okay? Then what will be the cost? Index. Instead of the loop RMS, so you need to calculate the cost of index. So in case of secondary index always the 11 plus the data. Selectivity, how many data? It's not always a primary key, so selectivity. Okay? So when you are using the clustering index is it will return a number of data and divide by the block. This is the number of blocks. Okay? Then the primary index is just one because only one record. Okay? So this part is the S side, inner table side index. And this is the same as the previous one. It's a join selected. How many of them are matched? Then matched, the record will be the sort. So that is the IO. So this is the inner table, the outer table. This is the inner table with the index. This is the joined one. Okay. So depending on the index, it can be slightly different. I'm going to skip this part. It depends on the hash performance that we've seen very briefly, the partition and the upset. So it's the H, but the H can be various depending on the hash algorithm. Okay, but it's the same idea actually. So this part. Okay. The next, sort merge. What is a sort merge? Sort merge is we are going to sort the DNO by DNO or the tuple left hand side. D number right hand side. Inner table, outer table, inner table. The driving table, driven table. Sort by the join condition. Then for example 1, 1, 1, 2, 2, 3, 3, 3, 1, 1, 2, 2. From the top, check whether or not they are safe. If yes, the keep. Otherwise, moving next, next, next. That is a sort and merge. So that is a sort merge. So that requires what? This is the cost of the sorting. So it depends on what kind of sorting algorithm you are using. Bubble sort, quick sort is very popular. Each and every DBMS has different variation of the sorting algorithm. So it's we don't know this one, but idea is the same. So we need to anyway read the one time of left hand side, one time of the right hand side, and join selectively. Okay. However, this one will depend on CS. This one is a hash. It's very fast in big table. If you have the very fast sorting algorithm. So not only just the algorithm, fast algorithm itself, the DBMS provide the hardware, the support, like the temporary space in the memory for sorting. So, for example, Oracle reserved the certain area as the temporary space. That area usually only used for sorting. Okay? Then that media should be fast. Many of the system administrator assign such a temporary space for in the memory base, because even though you lose the data, it's totally fine because it's a temporary. It's not permanent data. So they use the memory-based database for such a sorting. So that is a short merge. So let's take a look at the example of that. So we are going to use the same the database. It's a 10,000 and the record and 2,000 block, and our record is a department because we are going to join the two tables. First one is the employee and another one is the department. For the department is 125 and the block, number of block is 13. Okay? Then more information about the index. We have index, primary index. It's sorted by the record. It's a primary index. Their level is 1. Relatively small. The 100 only 25 department, right? So one level is enough. And secondary, we have the secondary index. Secondary index is the level is 2, okay? And what is this one? Selectivity is 1. For each department, one manager. Okay? So when you select the manager social security number, only one department will be returned. That is the selectivity. And joint selectivity between the employee and department is 1 over 125, which means the joint column is the between D number is equal to D NO is a D number. Okay? Then when you join with this one, among 125, only one data will be the joint. Okay? That is the joint selectivity. 1 over 125. Do you understand this joint selectivity? So among the 125 case, for the D NO is equal to D number, and one of them will be returned. However, if the D number is not the primary key of this one, okay, then maybe 2 data will be returned, 3 data will be returned. Like for example, the manager social security, and not manager social, supervisor and supervisor. One supervisor has the many, so it depends. Okay. At that time, such a buffering factor is we can keep the 4 join the column in one block. So using this information, we are going to optimize this query. So this is a query like the select from employee, department, where the D NO is equal to D number. If you have any other selection, yes, you can do that. Then we can apply even the heuristic algorithm, or we can calculate the cost for that. Anyway, so this is just a join. So at this time, how many different ways are possible? So first, employee, department. This is one option. Then department first, then employee. So for example, this one, so employee as the outer join. But this one is the department as the outer join, outer table. Okay? So this J2 is the employee as the outer, so there are 2 options. But we can use the different. This is the what? Nested roof join. This is a nested roof join. And this one is what? Single roof join. using what? The index. So first visit the employee, then using index. What kind of index? The D number. Secondary index. Using D number index, we can find the data. So this is the nested. This is a single loop with the index. Similarly, this one is the first department, then find, visit all the employee, so nested loop join. And this one is the using the index. What kind of index is this? It's a clustering index. Okay? For the department, we have the 1, 2, 3. So using 1, D number is 1. So D is a index, cluster index. Okay? So using cluster index, so this is the single loop join with cluster index. So we are going to find and compute the cost. First one, we can just apply the plug in the value. So BE is a 2000. We have 2000 block, and 2000 block times how many blocks for this? Is 13 blocks from the previous one. Previous statistics is 13 blocks. So times that this is already calculated 1 over 125, and number of record, then this is a joined column. Then divide by 4. Why divide by 4? We need to calculate the number of IO, the blocks. So how many blocks? How many records? Join the record for the block, so 4. Okay? So it depends. Sometimes when you join the very big table means a lot of column, and the longer the data type, then it will be smaller, which means the less number of records will be stored at one block. Okay, it depends. So if you calculate this one, output is the 30,000, around the 30,000. So then, next option is this one, nested loop join. It's quite similar, 13 and 13 times 2000. This is the same because it's the same join condition, but different order, so still same. So if you calculate this one, it's slightly less than the previous one. Because of that, even we can see that by changing the order of the join, performance will be different. Really, that happened a lot. So by changing the join order, it's a huge difference. Then the third option is a single loop join with using the index. So this part will be different. So always level plus 1. Okay. So it's for each the record of the employee and level plus 1. Then this is the same part. So then calculate. It's 24,000. Okay. Then this one from the department using the index, cluster index at this time. So 120 for each record, then the 2 plus the 80, we already calculated this one before. Then it's 12,000. Then which one will be selected by the query optimizer? Last one, because it's the lowest cost. So query optimizer will make the output of the query optimization is execution plan. Okay? So first access the department. Then using cluster index, find the employee. Then return the data. This is the execution plan. Okay? Question? Intuitively, very simple. So we try to find the root cause, but if you practice, it's not easy. Also, right now you should be able to understand why the performance will be different when I change the order of the table. This is one example. One of the students submitted this query, and another student submitted this one. We are using rule-based optimizer, not cost-based optimizer. So rule-based optimizer, which means we are not going to calculate the cost. Any difference between this one and previous one? Previous one is employee, department. Any difference? If you are using cost-based optimizer means we are going to calculate all the cost, then find the lowest one. Then it's the same. Okay? No matter how you sum it, as long as the output is the same, the query execution plan will be the same. However, we are not going to use that, the cost function, instead the rule-based optimizer. Do you think any difference? Always the database access the last one first if you are not using cost-based optimizer. So in this case, employee first, then department. In this case, department first, then employee. So as you can see, their cost will be different. Their performance will be different. So be careful when you are using the rule-based optimizer. So you need to know what types of the optimizer you are using in your database. So you can ask your administrator. Then when you code, when you make the SQL, it can be different. Okay. There are some other factors you can consider, but it's not a major. I'm going to skip. So I will use another PowerPoint file to explain about the rule-based and the cost-based optimizer later. Okay. This is an example of the Oracle optimizer, but it is the truth. The query optimizer in Oracle is one of the best ones. So that is because of that, the Oracle is a top market share and is well known for the online transaction processing system because their optimizer is working very well. So this is slide to show the comparison between rule-based optimizer and cost-based optimizer. Nowadays, cost-based optimizer is the default. So if you do not change anything, it's a cost-based optimizer. But it was not in the old version of the Oracle 7 and 8. The default was the rule-based optimizer. Why? Because their query optimizer was not stable at the time. But nowadays, they believe the query optimizer algorithm is pretty much work. However, still, their accuracy level is 80%. In other words, 20% of the query is direct the slower execution plan. Okay, let's take a quickly look at the optimizer. We already seen this one. This is an example of the rule-based optimizer. It has a ranking of how to access the data. So first one is a low ID. Low ID means it's kind of block ID. It's a directed fastest way to access the data. It's only used in the Oracle, but the other DBMS use similar. So this is the fastest way. Second is using the cluster join. Third is a hash cluster. The fourth is a unique, and so on. Last one is full table scan. So if there's any from the query, if there's, for example, any condition like the n, low ID is equal to blah 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 blah, then automatically this one will be selected. This is a rule-based optimizer. Cost-based optimizer by accessing all the, what is this? What are they? It's a catalog database. Do you remember what is a catalog database? It's a metadata. So one of the benefits of using the DBMS database approach is what? Database keep all the metadata inside the database. Because of that, you don't have to define any data structure in your application. Okay? Think about what if you are using the file system. You need to know what is a file name and where is how many bytes are for first name, last name. You should know. However, using the database, all such information are in the database. That database is called the catalog database. Catalog database like the catalog of your shopping. Okay, you can look up some information. Similarly, all database set is in the catalog database. So very straightforward. Tables. DBA underbar table means table information. DBA underbar tab underbar column is a column information. DBA underbar indexes is an index information, and so on. By searching such a value, then we have the cost per case. Then calculate the cost, then finally access the data. Okay. There are other factors that can consider, like the order by aggregation, but we have looked at the two main operations, selection and join operation. The different types of the join has a different. Okay. However, as I said, not always query optimizers decisions are correct. Okay, sometimes it can direct the wrong direction. For example, when I search the Google always shows the fastest way. Not always is correct. Sometimes it doesn't reflect the unexpected condition or whatever, so it directed to take the ferry and take the Long Island Express, so it will take a longer time. So how to avoid? So we decided to use the cost-based optimizer, but obviously this is not the right way. At that time you can ignore such a direction. Then take the local way. Okay. Similarly, in Oracle, nowadays many of the DBMS, RDBMS adapt such idea. It's called a hint. Hint means override. Ignore the optimizer decision. Okay. Then direct my way. So you can give such a direction that is called a hint. For example, this is the hint, like why don't you access using full S? Or why don't you use the index? Why don't you use the join? Why don't you use the no index, something like that? You can direct the route to access the data. That is called a hint. Okay. Nowadays, this hint is adapted to many other RDBMS because it's a very convenient, many people are using. Okay, then one more thing. What mostly nowadays is recommended to use the CBO because you cannot consider all different cases. Just in case, you can use the hint. Then, what is the problem of the drawback of using the CBO? What is the main problem? Cost-based optimizer. It looks like good, okay? Reasonably suggests the fastest way. What will be the problem of the cost-based optimizer? It depends on statistics. You need the information. In our previous example, we already gave the number of blocks, number of joint selectivity, number of what. What about the real database? Who is in charge of that? Database administrator need to collect such information. Manually? No, it's not possible. So DBMS provide a tool to collect such a statistic of your database. For example, Oracle this is not the standard, so it's not the standard comment, but Oracle used analyze comment, analyze table, analyze the database. If you run the analyze command, the DBMS access all the table data index and collect all the information. Then provide such as statistics. Then the optimizer can calculate the cost. Problem? It takes a time to collect the information. If I need to collect all student information, very detailed. What are you doing? From the 7 to 5 a.m. and 5 every minute, every time, it will take a long time to advise all the students, right? So instead, database use the sampling instead of the entire database. 1% of the data then shows the estimate. Yes, how many blocks do you need? How many IOs are needed, and what is the level of index, something like that. And also, it should be frequently updated. Not very frequently, reasonably, okay? If your table database is never updated, it's only read-only data, you can do just one time. However, if your database is updated every day, so you need to analyze the data, not every day, but mostly every week, something like that. Okay? So one of the main job of the database administrator is keep updating, keep running this command to find the fastest way the correctly. So that is the query optimizer. Okay. Any question in the query processing and query optimizer? No? Okay. Definitely, this is one of the main questions of your final exam. Oh, by the way, final exam will cover from the beginning to end. Okay. So because we didn't have the midterm exam, that will cover all the topic that we have done. However, I believe that if you have done all the homework and pop-up quiz or any assignment in the classroom, okay, pretty much, and any handout, so pretty much it's a very easy exam for you guys, okay? So I'm not going to very picky to make the question like whether this is a plural or the singular. So, but from any activity, including project also, okay, including project. So if you have done regularly the class activity, I don't think you need the additional the study time to prepare your final exam. Do not believe all I suggest is based on the ideal student, okay? But that means the final exam will not be very tough exam. So please try to review any class activity. Okay? Definitely, this will be part of your final exam. Then this one, next topic is the transaction. Long time ago, what is the top DBMS, RDBMS in the market? First one. Which one is the first market share? Recently, some of the reports said SQL Server is the first one, but in enterprise level, which means in the reasonably the big company, they use Oracle database. Oracle is the first. Oracle is nowadays not only the database company, it's just a general software company. When I visited, as you know, in the middle of the semester, I visited Korea to attend the conference and to visit my hometown. Then I met a couple of the engineers who still work for the database. They said nowadays Oracle hire a lot of employees worldwide. For what? Database engineer? No. Salesman? No. It's kind of salesman, similar to something who can combine their product and sell as a package, as a bundle. Kind of the one who make the new product by combining existing product. For example, I have the Microsoft, the Excel, I have the database something, Excel plus the Oracle is something ABC product. Because Oracle merged a lot of companies. Starting from the database, but some ERP analyze and business intelligence tool, sometimes the reporting tool, and sometimes HR, and many. Even they do not know how many products they have. And it's very hard to make the strategy, the business strategy. So they decide, it's kind of the cloud. Okay? It's a pool of the software they have. Nobody knows how many products they have. Because every day they merge by the new company or the small company, And so then their job, they hire the person, they can take a look at their product, then combine this one and this one, then sell together to the customer. Okay, so nowadays that is what Oracle is doing. Then Oracle is anyways still many people believe the top market share. And who else? The next one definitely Microsoft SQL Server. Then followed by IBM DB2. DB2 is the mid range. So Microsoft product as user it focuses on some medium or small size the company or the individual. And what else? We have Ingress is close to the object-oriented concept, but still IDBMS. We have MySQL. MySQL is nowadays part of the Oracle, but it's well known for the open source. It's a free software, free the IDBMS. Do you know Sybase? Sybase also very well known the IDBMS, but nowadays it's much behind. But people say, especially in the research and the academia, Sybase is one of the top, best relational database. It followed exactly what Dr. E.F. proposed and tried to focus on the performance, not the business requirement, said the performance and so on. So Sybase has been believed is one of the best software in terms of the algorithm and database concept. So, just like the other Microsoft product, SQL Server actually developed for single user system. So like the Windows, the 95, Windows 3.1, it's a single user operating system, right? You don't have to worry about other user. You don't have to worry about the synchronization issues because it's only single user system. I can update the data, I can read the data whenever I want. Then they realize that they need to change the direction for the multi-user system as a server. Because of that, Microsoft gave up the single user system after the 98. Instead, Microsoft the Windows NT. Okay, then the go. But still, so single user. Many people use a personalized system, but it supports multi-user. It's the same problem in the database. Yeah. Do you know how Microsoft SQL Server solved that problem? Actually, they purchased the transaction manager from the Sybase, the module. So right now, the transaction manager in the SQL Server is originally from the Sybase. So we are going to discuss about the transaction processing. Why we need a transaction? What is a transaction? How to implement such a transaction? What is a transaction, by the way? Anyone? Operation. What kind of operation? In computer system, yes.
Financial operations.
Financial? Only financial operation? So every time, as a computer science student or a computer science researcher, you mention about the transaction. My transaction is slow, my transaction is fast. What about my transaction and number of transactions? What does that mean, transactions? Go back to the basic of the computer system. What is a basic operation of the computer? Basic of basic. Processing? Who process? CPU. And what is the basic operation of the CPU? Instruction. It's assembly instruction. Okay? What happens when you compile your source code? You have the bunch of sequence of instruction. So instruction, can you divide the instruction into two operations? No. Instruction is atomic. Once you start, it will be done or fail. So that is the instruction. However, when you update the data from the memory, read the data memory and update the data, how many operations do you need? such as how many instructions? You need several instructions. Move instruction from memory to register and calculate, increment, decrement, and subtract, and the add the unit another operation. Then move such a result from the register to the memory. At least the instructions are needed. What if in the middle of the data, the process, read the data and the update, we cannot guarantee the output. That is called race condition. So multiple processes are racing for the same data, racing. So that is called the synchronization problem. So how do you solve that synchronization problem in operating system? Do you remember? I think some of you guys are taking my operating system class. Who are taking? So you are taking. So what is the solution? We define critical section, right? Whenever you access the shared data, select only one process can enter critical section, then that is the midterm exam, right? So that is the critical section problem. In database, so critical section, we need some the overhead. We need to decide that there might be some starvation. Also, not all the critical section problem synchronization solution are perfect. We need more. So if we lose some data in the database, it's critical. In operating system, sometimes it's not that critical. We can ignore something such a data but database is critical. So we are going to define another level of such an operation that is called the transaction. Transaction consists of a number of operation, basic operation. For example, what can be the basic operation in database? Read the data, write the data. Read and write are the basic operation. So in one transaction, how many read and write? There are many read and write the data. So for example, when you submit the disk query, a lot of the read operation. Also, inside the disk query, even there exists the write the data IO. Okay? After you join the data, it should be written to the somewhere in your memory or the secondary storage. So read and write, a lot of read and write. But it should be group. So that group is called transactions. So transaction is a logical concept of the processing. It's a group of operation. For what? To support database consistency. What does that mean? Consistent. Consistent. What is so inconsistent? Inconsistent means we cannot believe the data, right? Consistent means we believe the data, update or read, delete, any operation, we believe the data. If the database is not believable, then nobody uses. So database should be consistent. So to keep the consistent, we are going to use the concept of transaction instead of the synchronization problem in operating system. If you take a look at your operating system textbook, probably chapter 6, you will see end of the chapter transaction concept. Okay, but I didn't focus on that part because we are going to deal with the transaction in the database. So in this chapter, we will take a look at such a transaction. So single user system, we don't have to worry about too much because it's only one user system. However, multi-user system, we need to consider such a transaction management. Okay? So transaction is a logical unit. Like combination of a lot of read and write. So basically, the database has two different operations, read and write. It's a combination of the read and write. Then how can we define? This is one transaction, this is another transaction, and so on. Because we learned the transaction is the logical concept of the group of the operations. number of operations. But how can you define this is one transaction, this is another transaction? So to clarify such a boundary of the transaction, always transaction must start with a begin transaction comment. Then end with end transaction. Have you ever used a begin transaction or end transaction? Nobody used, but we are using. Why? Because application level automatically. For example, when you log on the SQL Plus, automatically begin transaction will be submitted. So your transaction, whether or not you realize or even though you don't realize, it's internally begin transaction is started. Then when you log on, okay, it depends on the option, but mostly it's the end transaction will be submitted. There's another the operation that can end the transaction we will see. So always the transaction should be begin transaction and end transaction. This inside between them there are a lot of operations. Read, write, whatever. Okay? Then this group of operation will be applied together. If something happened in the middle of transaction, we update the data A to B, but in the middle of something happened, like the transaction is killed, it's terminated. Then what happened? This data should be go back to the original. So all these operations work together until end of the transaction. That is a transaction. Okay. Okay, there are two types of the operation that you need to keep in the database: read and write. For the item, but database has granularity, which means different level of the data item. So we said the item X. That item X can be column value, higher level record row, and higher level table, higher level entire database. So depending on the data item, you can read the data, or you can write the data of a specific column, or the entire record, or the entire log, or sometimes the entire database. Okay? So you can, for this granularity, you can read and write the data. Then first take a look at this one. This slide shows clearly the state of the transaction. As I said, transaction starts with always the begin transaction. Then end transaction. There are two ways to end your transaction, database transaction. One is fail. Fail means obviously we are not going to apply any change after begin. That is called abort. So failed transaction. Another one is commit. It's a yes. It's a commit. That is the reason. Did you run the commit or rollback in your the SQL, the training? Yes, that is the rollback means abort, going back. Okay, and end transaction. And commit means permanently apply. I'd like to end the transaction, then permanently apply. Until you commit your data, changed data will not be applied to your database because of this one. Sometimes there is a partially committed, that is called checkpoint. So if your transaction is too long, I'd like to keep the current. It's not end of a transaction, but I want to keep the current change, partially commit, partially apply to the system. Okay? At that time, you can create the checkpoint. Then partially, up to this point, partially apply. Later, you can go back still. Later, you can roll back. If you want, at the end of the almost transaction, I believe this is wrong. So I'd like to abort the entire transaction. Yes, you can do that. Or you can make the several checkpoint. Okay? So that is the begin and end transaction in the database. What about the database programming? So I'd like to use the .NET, okay? Then the ASP.NET ASP, then I have the something query inside, and I never use the commit or I never use the begin transaction, but in the database programming, so .NET or the JDBC or any other programming language, when you submit, okay, the query automatically start the begin transaction, then end transaction. Also, explicitly you can commit your data, or end transaction is committed. Okay? So there are different states, the active state, and partially commit is a checkpoint, and commit is a permanently apply, and terminate, and so on. Then, so why do we need such a transaction? We try to avoid such a problem, abnormal situation, lost update problem. Lost update problem is let's say that there are two processes, process 1 and process 2. So this is timeline. Okay? Then, so this one, there is a shared data A. I'd like to change it, the A to B. So A, read the data, A to B. It's not done yet, okay? But process 2, read the data A. Almost the same before update. Then this one update to C. Okay? Update, this time C. What is the final value of A? Should be C, right? For the process 1 point of view, updated data is lost, okay? Because we do not have the synchronization solution. It's a racing condition. So that is called lost update problem. Because we do not have the transaction concept. So if we apply the transaction concept, begin transaction. During the begin transaction, yes, this is okay. It's isolated. So A. Then when P2 read the data, it is doesn't matter still A, then C. Okay? Then until when? It's a commit. If this one is commit, if this one is commit, then it will be C. However, there is a locking problem. You cannot update the data while the other one is holding the shared data. Okay? You can read the data that is held by this one. So this one cannot update the data until commit. Then commit, then you can read and update the data using transaction. That is a loss update problem. Temporary update the problem is the process 1 is update the data. Okay. What about so there are employee salary information. Salary information is a 10% the increase. So I'd like to update all the salary. So while this update is processing, I check my salary is increased. But what if this update is a failed later? So I read the data is updated, it's a 10% increase, but in the middle of the transaction, update is a fail. Okay? Then all the update, the temporary update will be lost. It's only temporary data. Okay? Because there is no concept of the transaction. Incorrect summary problem is frequently happen. So I'd like to sum up all the salary. It takes 1 hour to sum. So select the sum of the salary from the employee, and it takes 1 hour. Okay. Then in the middle of the selection, some of the salary are updated. Then what happened? Is it based on the beginning of the process, or just apply the change data? So we cannot guarantee. the output. So, because that is called the incorrect summary problem. Why? Because we do not have the transaction control, transaction management. So, that is the concept of the transaction. So, transaction always start with the begin transaction and end with the end transaction. Okay, in the middle between we have the number of the read and write operation. Okay, there are several the operation to implement the transaction. Commit, as you have seen, commit is permanently applied. Rollback is abort, go back to the original data. One common mistake of the commit transaction. When you commit your transaction, what happens? It's permanently applied to your system? Yes, that's true. However, that doesn't permanent data does not mean writing the data in the hard disk drive. Okay? Still is in the memory. Okay? For example, this is our system, and this is our memory. So when you update the data A, at the update A to B, first you need to read this one, A. Okay? Then update to the B. Okay? When you commit, it's permanently applied. Not to hard disk drive yet. Okay? It's in the memory. How? Another transaction select the data, this one, then because it's in the memory and it's about as a cache, it can be the return, the new data. Problem, what if this system is crashed? Because it's a memory, it's a volatile, you lose the data without power. Right? So still A, but database should be stable, permanent. Then how can you? We will see the solution later in the recovery problem. It's called the write ahead log. So using the log, we can actually recover the data. That is called the redo operation. I think that maybe next class we will see. Oh, that's the next slide. I think that we have a time. So we will see what is a redo and what is a undo. So one more thing, when you commit, when you end the transaction, there is one more operation. That is your operation update A to B. This operation only. Operation will be stored at the secondary storage. Usually this storage is called the log or journal. So update A to B. Not the update the data in the hard disk drive. Oh, by the way, why we do not update the data in the hard disk drive? Even though commit. This may be a good question for your final exam. Why? Takes a long time. Okay? Takes a long time because the writing to the hard disk drive is much longer than the memory. So instead of writing the updated data right away, we are going to defer the writing. It's called the deferred writing. Deferred writing. Deferred writing means we keep some update data. Then when system is idle or is a available resource, then write to the hard disk drive. Okay? So deferred writing. We keep the such update data in the memory from time to time first. Problem is before it's committed, but before flushed out to the hard disk drive, it's disconnected. That is a problem. So how can we restore this one? When you start up your system, check this log data. Update A to B. Then check the real data in the hard disk drive. Is it A or B? Still A. That means we need to execute this command again. Then A will be changed to the B. That means redo operation. You can redo the operation if database is not consistent. To keep the consistency, so we can redo the operation. That is a redo operation. Undo means it's opposite, right? Go back. Undo means sometimes I update the data, 10 millions of the data, okay? It's one transaction, update A to the employee table, but it takes 10 hours. We cannot keep all changing the data in the memory. Even though it's not committed, it will be applied to the hard disk drive due to the limitation of your memory. Okay, it's not committed, but applied to the hard disk drive. Then system crashes. Check log and the hard disk drive. There's no information about the update because this information will be logged at the end of the transaction. But this one is a change. This one is a B. Supposed to be A. So at the time you can undo. Go back to the operation. So it will be A. So this is a undo and redo to keep the consistency of your database. There are two main operations to keep the consistency of your transaction. One is the undo. Undo is go back to original data. Okay? It's not committed, but applied to your hard disk drive. Redo is committed, supposed to be updated, but not applied to your hard disk drive. Then redo that operation. That is the undo and redo. So using this one, actually these two operations will be used for recovery. What is a recovery? Backup and recovery. Backup is a copy your data. Okay, not only database, but any the computer system should be backup. For what? Recovery purpose, in case something happens, failure. Failure means it's not only for the crash, the transaction failure, or the system the failure, even entire your site can be failure, like the 9/11. During the 9/11, the building collapsed, so IT department is collapsed. So we need to restore the data using backup data. At that time, that backup and restore include nothing but undo and redo operation. Redo and undo, redo and undo. At that time, we need such a log, system log and journal data. That is the called write ahead log. Okay, so we will see a little bit more about such a transaction in the next class, how to use the redo the log data for the transaction management. Then we will see the property of the transaction, which is very popular, ACID, the property of the transaction. So we will see such a thing. Okay. Any question? So yes.
So you know that where's the store? Is it the memory or
the store of this one?
Yeah.
This is the secondary storage, your hard disk drive.
No, I mean the raw data.
Log it should be, must be the secondary storage, permanent the storage. Okay? Somebody may be curious. Instead of writing the log, why don't we update the data? But even though your statement is simple, in this SQL can update the 10 millions of data, right? So because of that, we try to keep this statement only. Okay, that's a good question. Then we will see on Monday. Okay, so why don't you keep working for the project B? Then after the Thanksgiving, we will have a demonstration time. So for the IoT, I will give the more detailed information through the campus message. Okay.